Opening scene: cinematic shots of highways, drones flying over busy Indian expressways, machines working. Building a highway seems simple, connecting 2 points with a straight line. But in reality, designing a highway in India is a complex engineering marp. Full of science, precision, and technology, all aimed at making your journey safer, faster, and smoother. Welcome to Civil Engineering Edge. In today's video, we'll explore how highways are designed in India using the latest standards, advanced machinery, and critical safety precautions. Let's get started. Section 1. The Big Picture. What is highway design? Highway design isn't just about drawing lines on a map. It's about solving thousands of tiny engineering puzzles, balancing speed, safety, traffic flow, terrain challenges, and environmental impact. In India, highway designs follow guidelines provided by the Indian Roads Congress (IRC) and the Ministry of Road Transport and Highways (MoRTH). Section 2. Key elements of highway design. 1. Roadway cross-section. When you cut across a highway, the cross-section tells you everything. The number of lanes, lane width, medians, shoulders, drainage systems, sidewalks, and even safety barriers. Why it matters? Cross-sections ensure enough space for vehicles, manage traffic smoothly, and maintain proper water drainage. Fun fact: roads are never completely flat. They are slightly sloped to prevent water from accumulating, which could lead to dangerous hydroplaning or icy surfaces. 2. Alignment. Alignment means the path the highway takes, horizontally and vertically. Horizontal alignment defines curves and straight sections. Vertical alignment decides ups and downs, gradients and slopes. Why it matters? Good alignment ensures that vehicles can maintain safe speeds without sudden braking, sharp turns, or skidding. 3. Roadway profile. Profile refers to how the elevation of the road changes along its length. Engineers plan gradual slopes to handle vehicle acceleration, drainage, and visibility. Section 3. Latest machines used in highway construction. Modern machines revolutionizing Indian highways. 3D pavers automatically adjust layers for smoother roads. Slipform pavers for seamless concrete paving of highways. Cold milling machines to quickly remove old road surfaces. Sensor-based graders to achieve millimeter-perfect road levels. Intelligent compactors ensure even compaction with real-time data feedback. Drones and survey robots for fast, high-accuracy mapping and inspection. Section 4. Benefits of well-designed highways. Faster travel. Well-designed highways mean higher speeds and lower fuel consumption. Increased safety. Proper slopes, signage, and barriers save lives every day. Comfort. Smoother rides reduce vehicle wear and driver fatigue. Economic growth. Highways open up new areas for business, tourism, and industries. Section 5. Safety precautions in highway design. Highways are designed keeping safety as the #1 priority. Key safety measures. Proper superelevation on curves to prevent vehicles from skidding outward. Crash barriers at dangerous spots to stop vehicles safely. Road markings and signage for driver guidance. Service lanes for emergencies. Adequate lighting in tunnels and critical points. Pedestrian crossings and overpasses in populated areas. Highway designs must also consider natural disasters like floods and earthquakes. Drainage, embankments, and flexible pavements are planned accordingly. Section 6. How speed limits are decided. Speed isn't just randomly assigned. Engineers calculate safe speeds based on terrain type: plain, hilly, curvature radius, superelevation, visibility distance, traffic load. For example, in plain terrain, design speed may be 100 kilometers per hour, while in mountainous regions, it could drop to 50 kilometers per hour. Section of final thoughts. Over. Next time you're cruising on a highway, remember, every curve, every slope, every sign is the result of meticulous planning, engineering, expertise, and endless testing. Modern highways are not just roads. They are lifelines built with cutting-edge technology, designed for safety and crafted for comfort. End credits roll with drone shots of Indian expressways at sunset. Hyper-realistic 3D sensor-based graders to achieve millimeter-perfect road levels. Ultra-realistic 3D intelligent compactors ensure even compaction with real-time data feedback. On Indian Road. Section 7. Superelevation and why highways are banked. Ever wondered why highways curve so smoothly, almost tilting you gently into the seat when you take a turn? That's no accident. It's because of superelevation. Normally, a vehicle needs a centripetal force to go around a curve. On a flat road, this force comes entirely from the friction between tires and the road surface. But what if it rains? Or if a vehicle's tires are worn out? The friction decreases, making turns risky. Imagine rolling a ball on a flat road. It would just continue in a straight line at the turn because there's no grip. Vehicles behave similarly. Superelevation solves this problem by raising the outer edge of the road around a curve or banking it. Engineers reduce the dependence on tire friction. The tilted surface creates a normal force that helps vehicles navigate safely even with reduced tire grip. Get the angle of the road just right, and a car or even a cup of coffee inside the car will stay perfectly stable around a curve without spilling. Higher speeds need steeper banking, and that's why sharper bends on highways are carefully designed with more superelevation. It even reduces the risk of rollovers, especially for heavy trucks and buses, by managing the center of gravity more effectively. Section 8. Curve radius and spiral transitions. Besides banking, the radius of the curve is another critical safety factor. Tighter curves demand greater centripetal force, making them more dangerous. That's why Indian highway design standards ensure that high-speed roads have gentle, wide curves. But there's another challenge. You can't jump directly from a straight path which has an infinite radius to a sharp curve. It would cause a sudden jolt. Think about it. If you had to yank your steering wheel all at once to take a turn, it would be uncomfortable and dangerous. Spiral easements fix this. Spirals are gentle transitional curves where the bend gradually increases. They allow drivers to slowly and smoothly turn the steering wheel instead of jerking it suddenly. This design makes highway driving not only safer but also much more comfortable. Section 9. Lane widening around curves. Have you ever felt like the lane becomes a little wider when you take a turn on the highway? You're not imagining it? Engineers intentionally widen lanes around curves. Why? Because during a turn, vehicles, especially large trucks, don't track perfectly straight. Also, the shifting forces on tires need some extra space. This subtle widening gives drivers a margin of safety without them even noticing. Section 10. Sight distance. Seeing what's ahead. One final but crucial factor is sight distance, the distance a driver needs to see ahead and react safely. Sight distance depends on two major factors: how fast you're traveling, how quickly you can react. Faster speeds and slower reactions need longer sight distances. That's why, around curves, designers ensure that there are no obstacles blocking your view, like trees, buildings, or even steep slopes. Clear visibility saves lives, allowing drivers to brake, change lanes, or steer away from danger in time. The hidden genius behind every highway. From the slight tilt of a highway curve to the gradual widening of lanes, two perfectly calculated sight lines. Every small detail on a highway is the result of using the latest machines, design software, and years of safety research. India's highways are built not just for speed, but for safety, comfort, and efficiency. End screen showing construction sites, happy families driving, and futuristic highways. Hyper-realistic 3D pavers automatically adjust layers for smoother roads on Indian roads. Hyper-realistic 3D cold milling machines to quickly remove old road surfaces on Indian roadworks. Hyper-realistic 3D sensor-based graders to achieve millimeter-perfect road levels. Section 11. Sight distance challenges on curves. Designing a highway isn't just about making curves wide enough, it's also about ensuring clear sight distance. The distance needed to stop a vehicle is different from the distance needed to safely overtake or avoid an obstacle. Even if a curve is gentle enough to drive through, an obstacle, like dense trees or a rock outcrop, can block your view. In such cases, engineers have two choices. Either remove the obstacle or make the curve even gentler so that drivers have more time to react. Section 12. The vertical profile roads go up and down to. Roadways aren't just about horizontal curves, they move up and down to, following the landscape. This vertical movement is called the road profile or vertical alignment. Grades, the slope of the road, are crucial. Roads that are too steep make it difficult, especially for heavy trucks climbing uphill or braking downhill. Smooth transitions between uphill and downhill sections are necessary not just for comfort, but also for safety. Crest curves, those that rise like a hilltop, are particularly tricky. As you drive up, you can't see what's waiting beyond the top. If the curve is too sharp, you might not spot a stalled car, animal, or obstacle in time. To maintain safe sight distance, crest curves must be designed gently. On the other hand, sag curves, where the road dips down, usually allow good visibility during the day. But at night, things change. Vehicles rely on headlights, and if the sag curve is too sharp, your lights may not illuminate far enough ahead. Therefore, sag curves also need to be gradual to maintain headlight visibility and ensure nighttime safety. Section 13. The art of highway design. Believe it or not, highway design is not just pure physics and math, it's also an art form. Engineers use formulas to calculate everything from the amount of superelevation to the minimum radius of a curve to the ideal vertical grade. But there's also judgment, experience, and even psychology involved. Every country and often every state or region has its own guidelines and standards. Yet, good designers go beyond just following codes. They think about the driver's experience, how the landscape unfolds, how the turns feel, and how attention is maintained. That's why modern highways feel less like a series of straight lines with sharp bends and more like a continuous, flowing journey. Gentle curves, wide open views, and gradual transitions not only make driving more enjoyable, they also keep drivers more alert and engaged, reducing accidents. The hidden craft behind every journey. Every highway you drive on represents thousands of decisions made carefully by engineers, from slope to curve, from banking angles to sight distance. Everything is designed to make your journey safe, smooth, and beautiful. Next time you're on a road trip or even your daily commute, take a moment to appreciate the incredible engineering beneath your wheels. If you enjoyed this video, don't forget to like, share, and subscribe to Civil Engineering Edge. We bring you the unseen stories and secrets behind the infrastructure that powers our world. Thanks for watching, and we'll see you in the next journey.